In the deepest, darkest reaches of the cosmos, there are these lonely fireflies, entirely unable to light up the eternal night around them. Welcome to this explainer, where we're going to dive into the absolute rarest galaxies known to humanity. We're talking about isolated, brilliantly blue galaxies that are literally aging in slow motion. Strap in, because we're leaving Earth behind and heading into the most terrifying, yet strangely beautiful, empty spaces in the universe. So what actually happens when you fall off the cosmic cliff into perfect, absolute darkness? Picture this. You're zooming away from Earth at thousands of times the speed of light. You fly past our entire solar neighborhood, you clear the Milky Way with all its 200 billion stars, and you just keep going. You push past the colossal Virgo supercluster, this massive wall of over 2,000 galaxies. But then, it just stops. The familiar glowing universe totally drops away, and you literally fall off a cliff into deep, suffocating blackness. And here's the wild part. We currently know of over 8,000 of these unfathomably large, empty spaces. Astronomers call them voids, and they just keep finding more of them. It turns out no matter how massive a cluster of galaxies might be, there's basically always an even larger, darker void sitting right next door. These aren't just little empty pockets, They are massive structural pillars that literally shape the entire universe. Which brings us to Section 1, the edge of the cliff. Leaving the lights behind. To put this suffocating emptiness into perspective, right on the edge of our own cosmic neighborhood sits the local void. It's this gigantic, empty bubble spanning a mind-bending 200 million light-years across. Think about that for a second. If the local void were somehow bright instead of pitch black, it would take up 40% of our night sky. Imagine stepping outside, looking up, and seeing almost half the sky completely dominated by a single, solid structure. That is the true, terrifying scale of the emptiness right next door to us. Let's plunge deeper in Section 2, Bubbles of Eternal Night. Plunging into the Boot supervoid. 300 million. That's the width in light-years of the Boot supervoid. It's a cosmic desert so incredibly massive that it absolutely should contain thousands of bright galaxies, based on how the rest of the universe looks. But instead, it offers nothing but an inescapable prison of blackness. If you were dropped dead center in there wouldn't be a single sign that the outside universe even exists. It's just silent blackness. No up, no down, no movement. Everywhere, forever. Now, you might be wondering, why don't galaxies just float into these voids? Well, it's because they tend to stick to the outer edges, kind of like reflections of light on soap bubbles. Gravity out there acts like this massive game of tug-of-war. Because there's almost zero mass inside the void, the dense cosmic web on the outside pulls things away. Galaxies are literally dragged out of the emptiness, forcing them to violently stick to the rims of these dark spaces. It's a tug-of-war where the void isn't even bothering to pull back. This leads right into Section 3, the loneliest fireflies. Life in the deep dark. Because if we look really closely, cutting through that pure blackness are these shimmering, completely invisible scaffolds. We're talking about faint tendrils of dark matter, and they penetrate deep into the void like bioluminescent cosmic lichen. They act as this sort of miniature echo of the much larger forest of dark matter that holds the whole universe together. And it turns out these delicate, creeping tendrils are the ultimate key to finding the absolute rarest objects in the cosmos. Right at the very tips of these dark matter tendrils sit the void galaxies. These are extremely rare, incredibly isolated galaxies that just shine like faint blue specks in this massive ocean of darkness. They really are like lonely fireflies, totally unable to light up the eternal night surrounding them. We are literally looking at the most isolated, lonely places known to exist anywhere. Let's unpack how they survive in Section 4, Aging in slow motion, a stark contrast of cosmic lifestyles. So in our Milky Way's neighborhood, things are chaotic. Galaxies are super active. The heavy gravity of neighbors is constantly pulling at them, causing violent collisions, rapid merging, and honestly really fast aging. But void galaxies? Entirely different story. Because they're completely isolated from that intense gravity, they live in this perfectly calm cosmic habitat. They're smaller, they stay brilliantly blue, and they literally age in peaceful, slow motion. Which brings up a fascinating point in Section 5, the last safe haven, hiding from the cosmic horror. As you can tell, void galaxies actually offer an unmatched,
ultimate refuge. They provide total isolation from those violent galactic collisions we just talked about, and they're completely protected from the devastating tug-of-war of the superclusters. Because they haven't been forcefully merged or torn apart, they are incredibly rich in untouched cosmic gas. They burn their fuel by birthing new stars at a much calmer, way slower rate. And because of this is the crazy part. Void galaxies could very well be the absolute last habitable places in our dying universe. The very last star ever born in the universe will probably light up right here in the deep dark.
Let's look at the timeline. Today, voids are growing while galaxies stick to their edges. But look ahead, roughly 100 trillion years into the future. It's fascinating, and maybe a little terrifying, to think that desperate alien races might eventually have to embark on this impossible journey to escape a dying universe. They might literally dive directly into the terrifying darkness just to find a safe haven in a void galaxy, doing whatever it takes to stretch their civilization's existence just a little bit longer. Moving to our final section, Section 6, the final darkness, dark energy, and the end of the web. So what's ultimately driving the growth of these terrifying bubbles of nothingness? The answer is dark energy, this incredibly mysterious force that's accelerating cosmic expansion. We can't actually see it doing anything inside our own galaxy because there's just way too much gravity pulling things together here. But inside these vast voids, that is literally the only place we can truly witness dark energy at work. It's violently stretching space, basically blowing up these bubbles of nothing from the inside out. And sadly, this brings us to the demise of the entire cosmic web. Step by step, that creeping emptiness is going to encroach on everything. First, the void bubbles are blown larger and larger by dark energy. Then, those beautiful galaxy filaments we see today are slowly ripped apart. Eventually, the walls of thousands of galaxies thin out and get pulled to the edges as two voids merge into one. And finally, expanding supervoids will completely crush all the clusters. The entire observable cosmos is eventually going to become just one gigantic void of nothingness. The universe is ultimately destined to become a place of absolute, silent blackness. But tucked away on those invisible tendrils of dark matter, these lonely, slow-aging fireflies just might outlast it all. It leaves us with a pretty haunting thought to wrap up our explainer today. When the ultimate cosmic darkness finally wins, will anyone be hiding out in those faint blue specks to witness the final fade to black?